Okay, everybody. Today we'll talk about. We have already finished that. First part. Let's see. Okay, so today we'll talk about the second part of the skeletal tissue. Okay? Where's that?
Oh, I'm sorry.
Okay. So, first we'll see the structure of a bone. Structure of a bone you have seen in last class. This time we'll see the microscopic structure of the bone. You have seen the microscopic structure of bone in your lab part, right? The structure of bone under microscope. So we'll just review that. Then we'll talk about the formation of bone, which is called ossification. How the bones are formed. Ossification is also called osteogenesis. Osteo means bone, genesis means production or formation. Two ways the bones are formed in your body. One is called intrachondral ossification and another is called intramembranous ossification. So those are two ways how the bones are formed in your body. We'll talk about that. Most of the bones are formed by intrachondral ossification, but few bones of your body are formed by intramembranous ossification. Then we'll talk about the blood supply of a long bone. Which blood vessels enter into the bone to provide oxygen and nutrition. Then we'll talk about the hormones. Two types of hormones work on the bones. You see, there are few hormones that help to grow the bones. Growth of the bones, one type of hormones. Another type of hormones work on the bones to regulate the calcium in your blood. So there are two groups of hormones. One group helps to grow the bones, another group helps to regulate the calcium in your blood. So we'll talk about those two types of hormones that work on the bones. Okay? So first, the structure of a compact bone. If you see a compact bone structure, it is actually a bundle of many columnar structures like this. So you see many columnar structures like this bundled together to form the compact bone. Very simple. Make sense? And each unit or columnar structure is called an osteon. So many osteons or columnar structures bundled together to form the compact bone. So osteon is the structural unit. Okay? So this whole thing is the compact bone, makes sense? And each structural unit or column is called what? Osteon. Is it clear? Okay. So now, this is the compact bone, and if I make a cross section, make a slice, and see under microscope, what I will see many rounds, right? Circles like this. So this is how, when we make slide, compact bone looks like this. You have seen that many round or circles. Each is an osteon, right? So these are osteons. Now if you see the structure of an osteon, in the center you have a canal that is called central canal. Makes sense? In the center of the osteon, right? Why you have a canal there? Blood vessels, arteries, veins and nerves, they pass through the central canal. Okay? So central canal contains what? Blood vessels, right? Very good. Blood vessels and nerves. Yeah, artery, vein, those are blood vessels and nerves. Okay? So that's the central canal. Each osteon has that. I'm showing one. Okay? Then around the central canal you have lacunae, tiny cavities. Those are called lacunae. Okay? Okay? Lacunae are small cavities like this. Okay? Tiny cavities. And inside the lacunae you have the bone cells. Those are called osteocytes. You already know. Mature bone cells, right? Osteocytes. So osteocytes reside inside the lacunae. Okay? So osteocytes in lacunae. So I can say this structure is osteocyte within lacunae. Okay? So all these lacunae house osteocytes. Like this. Okay? Now, you know these osteocytes are sitting inside the lacunae, right? But they are alive. They are not dead. They are what? Alive. So they need nutrition and oxygen. Make sense? So what happens? From the central canal, fine channels, very thin, like hair-like channels, go to lacunae, like this. And also, one lacunae is connected to another by those fine channels. And they take the nutrition and oxygen to the lacunae to give them to the osteocytes. So these fine channels are called canaliculi or canaliculi. Plural. Okay? So fine channels connecting the central canal to the lacunae as well as lacunae to lacunae. So the fluid containing nutrition and oxygen can go to the lacunae to keep the cells alive. Okay. Now the last thing, in between the lacunae, these spaces are filled with hard matrix of the bone that gives the stiff hardness of the bone. And this hard matrix of the bone is called lamella. Okay, so lamella is the hard matrix between the lacunae. L-A-M-E-L-L-A. Lamella is the hard what? Matrix of the bone. So that is the structure of the compact bone. Consists of many columnar structures. Those are the structural units and called osteons, right? And inside the osteons, you have these structures. Make sense? Okay. All these are like this. Okay. So So that is the structure of the compact bone. So this is these lacunae are very nicely arranged like this, circles, another circle like this, another circle like this. So they form kind of circles. Okay, so it's like tubes within tubes. This is a big tube, then a smaller tube, then further smaller tube like this. Okay, so that's how if you see the posture. Okay. Now, matrix is very hard and give the hardness of the bone. You see the central canal contains the artery, vein, and nerve. Okay, and they have shown lamella like circles that I have shown here. Okay, so this is one, another, around that. Here you see this is one ostium. This is another ostium, right? So many ostiums. And if you see the central canal, this is just a part of ostium, a slice of ostium. So you see the artery, vein, nerve, and you see the osteocytes in lacunae. Here you can see the lacunae without osteocyte. Osteocytes have been destroyed, so you can see the lacunae clearly, right? Those are the cavities, tiny cavities, and those cavities contain osteocytes. In spongy bone, if you see a spongy bone which is different than compact bone, there is no particular organized structure in spongy bone. Instead, you will see many trabeculae. Those are the processes inside the spongy bone, and in between trabeculae you have a lot of spaces where red bone marrow is located. So no osteons, no particular structure. So it is kind of unorganized structure. Okay. Now we'll see the chemical composition of the bone. Bone has two types of compounds, both organic and inorganic. So bones, if you see the chemical structure of bone tissue, it has organic compound and inorganic compound. Organic compound forms the osteoid and osteoid consists of fibers and matrix. Okay, and this matrix is the ground substance. Okay, and inorganic compounds include calcium and phosphate. So these are inorganic chemicals in the bone tissue. So organic part is called osteoid. Okay, organic part is called osteoid, and osteoid consists of fibers and the ground substances which forms the matrix. And mineral salts are the inorganic part, and that includes calcium and phosphate. Okay, about 65% of bony mass is given by inorganic. That means mineral salts. Okay, so you can write here inorganic, which is mineral salts. Okay, calcium, phosphate. and organic is osteoid. Okay? So that is the chemical composition of the bone. Now, ground substances include proteoglycans and glycoproteins. These two chemicals, ground substance, which is a part of organic, proteoglycans and glycoproteins. Okay? Those two chemicals. So now let's me quickly review. Okay? If you see the chemical composition of the bone, it has both what? Organic and inorganic. Is it clear? Organic part is also called osteoids. Okay? And it has fibers and ground substances. Okay? And ground substances includes proteoglycans and glycoproteins. Those two things. Okay? Now let's go to inorganic, which makes about 65% of mass. And inorganic part has the chemicals. Those are called calcium and phosphorus. Okay? Now, since the organic part has fibers, collagen fibers, the organic part gives the flexibility of the bone. Okay? You can little bit bend it without breaking. That flexibility is given by the fibers, right? You know, fibers give flexibility. And mineral salts, calcium phosphate is very hard, like cement, hard cement. Okay? So if you, this part gives the hardness of the bone. Make sense? Hardness of the bone. So this part gives the flexibility. That is also a strength. And this part gives what?
The hardness.
Hardness. Okay? Now, you tell me, if I destroy the fibers from the bone, what will happen if I try to bend it? Break, right? Easily. It will lose the flexibility. Make sense? And we can do that. Chemically, we can destroy the collagen fibers from the bone to see what's the function of collagen fibers. Okay? So that bone will be very fragile. Make sense? But if I keep the fibers but destroy the mineral salts, then what will happen? You will see it will be very, flexible. But the hardness is gone. Make sense? So those two together give the strength. Okay, very good. Now we'll talk about the ossification. Remember, I said ossification or osteogenesis means formation of bone or bone formation. Okay, formation of bone, which is also called ossification or osteogenesis, bone formation. Okay. Now, I said that the bones of your body comes or are formed in two ways. Remember, two ways. One is called Intramembranous Ossification and another is called Endochondral Ossification. So, intramembranous and endochondral. Most of the bones of your body are formed by endochondral ossification. Okay? Few bones are formed by intermembranous ossification. Is it clear? Okay. So which bones are formed by intermembranous ossification? Which few bones? Flat bones. Can you give me an example of flat bone? Yeah, many skull bones like parietal, right? Occipital, those are flat bones. Sternum, right? So those flat bones and the clavicles. These bones come from intramembranous ossification or formed by intramembranous ossification. Flat bones and clavicles. Is it clear? Okay. I'll ask it in the exam. Rest of the bones of your body, like your tibia, fibula, humerus, radius, ulnus, femur, right? Vertebrae, all those bones come from endochondral ossification. Now, intramembranous. Intra means what? Inside or outside?
Inside.
Inside, right? Intra. Endo means what? Inside or outside?
Outside.
Endo means inside. Okay. Exo means outside. Endo means what?
Inside.
Exo means?
Outside.
Okay. Exo, you know, I think.
Exit.
Exit, yeah, exo. So, intra and endo, same meaning. Intra means inside, right? Endo means inside. That's why intramembranous and endochondral is also called in many places, you will see, intrachondral. Makes sense? Same thing, same meaning, you can just use in both cases, right? Intrachondral, endochondral, same thing, right? Okay, so in intramembranous ossification, bones come from inside the membrane. Inside what? Membrane. That's why it is called intramembranous ossification. And intrachondral or endochondral, bones come from, chondro means, write it down, cartilage. Chondro means what? Cartilage. Osteo means what? Osteo? Bone. Osteo means bone, chondro means what? Cartilage. Okay? So intrachondral or endochondral means bones are formed from inside the cartilage. Okay, so first we'll see intramembranous ossification. Okay, what happens in intramembranous ossification? First you need a membrane. Okay, this is called mesenchymal membrane. Okay, mesenchyme is embryonic tissue. All connective tissue structures come from mesenchyme. Okay, you remember your bones are connective tissue, cartilages are connective tissue, blood is a connective tissue, fats are connective tissue, right? They are different from each other, right? But all of them, why they belong to connective tissue? Because the source is mesenchyme tissue, embryonic tissue, same source, okay? Bones, cartilages, fats, blood, ligaments, tendons, all belong to connective tissue because they all come from what? Mesenchyme, which is an embryonic tissue. So that mesenchyme or embryonic tissue forms a membrane. And inside the membrane, you have fibroblasts. Probably you have heard in first or second lecture I mentioned, fibroblasts produce fibers. So these are connective tissue cells, fibroblasts. Okay. So these are fibroblasts, these cells. What happens? First, few cells, those are located in the center of the membrane. These fibroblasts, since these are embryonic cells, they can be converted to any other type of cells. Okay, embryonic cells can be converted to different types of cells. So these fibroblasts in the center of the membrane will be converted to osteoblasts. You remember osteoblasts, young bone cells. Okay, so they will be converted to what? Osteoblasts, young bone cells. Okay, now these osteoblasts are young cells, right? Blasts. And I mentioned in last class, osteoblasts secrete the matrix, okay? Produce the matrix of the bone. So what will happen next? These osteoblasts will secrete matrix. Around them, okay? Okay. Then you must remember osteoblasts are young, and when they get older, the size gets big or small. I mentioned in last class. When you get old, smaller, right? Osteoblasts are healthy, right? And when they get old, right? They shrink. Make sense? And become osteocyte. Mature cells are osteocytes. Remember that? So osteoblasts become old, and those are osteocytes. So now let's see what happens. You see, they have secreted matrix, right, around them. And this matrix will become hard. And now, since the osteoblasts are getting old, they will do what? Shrink or get bigger? Shrink, right? And in osteocyte, in last class I showed there are processes. So what will happen? These cells shrink and get smaller, shrink or get smaller, so like this, and get processes. So these are osteocytes now. So osteoblasts will become osteocytes. Make sense? And matrix got hard by that. Matrix got what? Hard. So matrix will not move anymore, but osteoblasts will become osteocytes, smaller. So what will happen? A space will be created between the matrix and the osteocyte. Makes sense, right? Like you are big, around you, you have hard matrix. Now you got smaller, what will happen? A space will be created, right? Between the hard matrix and you. A gap. And that is called what? Lacunae. You remember? Cavities, right? So that's how we get lacunae and osteocytes inside them. That is the structure of bone, you remember? The osteocytes are housed inside those cavities called lacunae. So it will start in the center, then it will occur everywhere. So that is how a bone is formed from mesenchymal membrane. And that's why this type of ossification or bone formation is called intramembranous ossification. Okay? Just know, if I ask you, write those few things. So, quick review. First, mesenchymal membrane. What type of tissue is that? Embryonic tissue, right? And inside that membrane of embryonic tissue, you have fibroblasts, right? And those fibroblasts can be converted to any type of cells because those are embryonic stem cells, okay? So, in the center of the membrane, some fibroblasts will be converted to what? Osteoblasts, young bone cells, right? And they will secrete matrix around them, right? And matrix will become hard. And the osteoblasts will get smaller, right? And will become osteocytes. Make sense? Yes?
What are the little spikes off the osteocyte called? Is that the Lacunae or is that tiny little spikes?
Space.
The little spikes on it?
Oh, those are processes.
Thank you.
You know, the bone has processes, right? Like that. Extensions. Okay, so we'll get smaller, right? So a space will be created between the hard matrix and the cell body, okay? Osteocyte. And that is called the lacunae, right? So that is how we see in the bone that osteocytes are sitting inside the lacunae, okay? So that's how most of the flat bones and clavicles are formed. by intramembranous ossification. Okay. So if I just ask you, write those few things I mentioned now. Okay. Now another type of ossification, which is called endochondral or intrachondral. Endochondral or intrachondral ossification. Chondro means what? Anybody? Cartilage, right? That I just mentioned a few minutes ago. Chondro means cartilage. Whole fetal skeleton is what? Bone or cartilage? Whole fetal skeleton is cartilage. And I mentioned in last class, hyaline cartilage. What type of cartilage? Hyaline. So whole fetal skeleton is hyaline cartilage, and from that those cartilages, the bones are formed. We know that, right? That skeleton becomes bony skeleton. So this is a hyaline cartilage, and from this cartilage, the bone is formed. That's why that is called endochondral, from inside the cartilage. Okay. So what happens first? This is hyaline cartilage. Hyaline cartilage. Okay. In the center of the hyaline cartilage, these are chondrocytes, right? Chondro means cartilage, site is cell. I mentioned that. Chondrocytes, cartilaginous cells, mature cartilaginous cells, chondrocytes. And what will happen? Some chondrocytes will be converted to osteoblasts. Okay. So some chondrocytes will become osteoblasts in the center of the hyaline cartilage, and that area is called primary ossification center. Primary ossification center. Okay. These osteoblasts will do what? Will secrete a chemical that is called alkaline phosphate. So osteoblasts secrete alkaline phosphate, and that helps in calcium deposition of, you can write it down, that alkaline phosphate helps in deposition of minerals. The main minerals are calcium and phosphate. We have talked about that. Okay. So alkaline phosphate helps in mineral deposition. Deposition of minerals. So the minerals will form the matrix. Now what happens, you see, this is interesting. Let me draw here. Next step, the same cartilage here. So you have matrix, right? Hard matrix or minerals, and these osteoblasts will do what? Hypertrophy. This is something interesting happens. The osteoblasts will get bigger. That is called hypertrophy. Hypertrophy of osteoblasts. So these osteoblasts, those are in the center, in the primary ossification center, will enlarge, will gradually get bigger. Hypertrophy will occur. And at one point, they will rupture, they will burst. They will do what? Rupture. Okay? Gradually will get bigger, 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 occupy more space. Now just think that these cells got big in size, so they will occupy more space, right? And will rupture. Cell membranes will be destroyed. So a cavity will be formed. Make sense? Occupy more space, then what happens? They are destroyed. So a cavity will be formed there. And that is called the medullary cavity. Okay? So that's how the medullary cavity is formed. Medullary cavity. Okay? And that's the medullary cavity, formation of medullary cavity, and around the shaft of this, cartilage or newly formed bone, what will happen? Osteogenic cells. You know that osteogenic cells are the stem cells. They will secrete matrix here, and that will form a thin bony collar. Just know that a thin bony collar will be formed around the shaft. This is called bony collar. Around the shaft. Okay? So the last thing what will happen, let's see what happens in next step. This is the same cartilage, okay, here. So we already got the medullary cavity here, and we got bony collar here. In next step, what will happen? Osteoclasts around the medullary cavity. Osteoclasts are, giant cells they love to destroy. So they will become active, osteoclasts, and will make the cavity nice by destroying excess bone. Okay, so this is osteoclasts will also work there to polish the cavity by destroying excess bony structures there. Anyway, so now important thing here is a blood vessel will enter into the medullary cavity from outside and will branch like this. Okay, so this is a blood vessel. You need to know that. That is important step. So a blood vessel enters into the bone, into the medullary cavity, and branches like this. So blood penetration of blood vessels. Okay, and branching. And in this stage, another thing will happen. Two more ossification centers will be formed at the ends. These are called secondary ossification centers at the ends. Okay. This was primary, you remember, in the center of the shaft, primary ossification. Since these are appearing later, these are called secondary. Make sense? Primary is how many? One or two? One in the center of the shaft, right? And appear at the very beginning. Make sense? And secondary ossification centers appear at the ends. And those are called secondary because they arrive late. Okay? not the main one. And what will happen now, you see, this part became bone. It got medullary cavity, and bony collar will become thick and form the compact bone. So this part already become bone, and from secondary, the bone tissue will start to be formed. And now you see here, this is important, interesting. Bone formation has occurred here and will continue to grow. And from secondary, bone formation will occur and will continue to grow. So from primary, we'll go towards the ends like this, and from secondary towards the primary like this. And in between, you have cartilage still, which is not converted to bone, and this cartilage between primary and secondary, that is called growth plate. Some of you have heard, I believe, growth plate or epiphyseal plate. Okay, growth plate or epiphyseal plate. How many of you have heard growth plate? Okay, so at least few of you have heard, right? So you see, the bone formation will occur from primary and will get bigger like this, and secondary will appear, and bone formation will start from secondary too. So the bone is growing this way, bone is being formed this way, and the space in between is still cartilage. Okay, so that is the growth plate. Make sense? So gradually the growth plate will get what? Smaller, right? Make sense? As the bone will be formed from both directions, will get smaller, right? And at one point, when growth will be completed, it will remain as a thin line, a thin plate of cartilage that will never be converted to bone, will always remain as cartilage, hyaline cartilage. This is interesting. So in older people, you will find that thin plate of cartilage there. Okay. So this thin plate of cartilage will never be converted to bone, will remain as cartilage. Now this is a problem, because if you have a cartilage, thin plate of cartilage here, right, in the bone, long bone, then this is a weak point. Make sense? Because cartilage, where you have cartilage inside, it can easily break, right? So that is called epiphyseal fracture that happens. Okay, the head part can get detached from the shaft here, because this cartilage always remains as cartilage. Okay, so that is one. And also a thin layer of cartilage will remain as cartilage here at the ends, will never be converted to bone, and that is the joint cartilage or articular cartilage, you already know. So those two cartilages will never be converted to bone. One is at the end, that is covering the end of the bone, and another is here between the shaft and the ends. Okay, they will never be converted to bone. Okay, articular cartilage is very important, because you see, we know the joints, right? This is one bone, end of one bone, this is end of another bone, right? And the ends are covered with what? Cartilage, articular cartilage. We went over the joints, right? So those are hyaline cartilages, you must remember. Okay, why we get hyaline cartilage there? Because of this, right? That cartilage will never be converted to bone. Okay, why we get epiphyseal fracture? Because of this cartilage. Okay. Anyway, so that is how endochondral ossification occurs. We get bones from cartilage. Okay. Now quickly reviewing. Okay. So this is a hyaline cartilage in fetal skeleton. Okay. In endochondral ossification, in step 1, the chondrocytes, cartilaginous cells in the center of the shaft, will be converted to osteoblasts, and they will secrete alkaline phosphate. Okay, that will help mineral deposition. Number one, they will help what? Deposition of mineral. Okay, calcium phosphate. So that will form the matrix. Then osteoblasts will get bigger and bigger. Okay, hypertrophy. Is it clear? Occupy more space, right? And then rupture. So a cavity will be formed there, right? And then that cavity will be polished by osteoclasts. Those cells, love to destroy the bone. It's like, when you see a fracture in the wall of your house, you do what? You buy that white speckle? What is that called? That you put, yeah, you put that cement, right? There, to fill the gap, right? First. Then you do what?